This is Unit 3, Triangles, Preview Video 3.7, Side, 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 angle, side, angle, side, angle, 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 side, formal proofs. Sit tall. Close your eyes for a moment. Ready? Take a deep breath. Inhale. Hold your breath. And exhale. Alrighty, students, welcome to your last lesson in our longest unit of the semester, triangles. We're going to continue talking about shortcuts, triangle shortcuts, and introduce you to something called formal proofs. Don't forget date, time, location, as well as a parental or guardian sign-off. Let's just recap real quick our previous lesson. There are 4 triangle shortcuts: side, 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 angle, side, angle, side, angle, 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 side. We walked through the concept of proofs, informal proofs, and gifts, given, implied, freebies, talk through. This is the most critical skill of what are commonly called proofs, is to walk through the process of gift. So I'm going to do these 2 with you. Put your finger here, and first finger, not pen, finger, right there. And you're going to read out loud, lips moving, finger on the page. Ready? AC bisects BCD only. Angle B is congruent to angle D. Now, we take each piece of information and put it on the diagram. AC bisects BCD. Only. Angle B is congruent to angle D. That's our given information. Implied and freebies. Because of B and D, we have a pair of angles. Because of the bisector cutting that in half, we have another pair of angles. That's implied. Freebie, AC, it would be written like this: AC is congruent to AC. That's called reflexive. It's a pair of sides. Talk it through. So you see here we have a pair of angles, another pair of angles, and then a pair of sides. That side is physically touching only one pair of angles. Therefore, it is a tail, not a hamburger. So this would be angle, angle, side, or side, angle, angle. Let's try it again. Given. Right there, finger on the paper, lips moving, read it out loud. Now, hope you actually read that out loud. Finger on the paper. Let's trace. AB and DE are parallel. Point C is the midpoint of BE only. Midpoint going this way. Okay, we're done with our given. Implied, of course, because of the midpoint, you get a pair of sides being equal. Also, I'm just going to give some numbers here, angles 1 and 2 and 3 and 4. Because of the parallel sides, you can get these angles congruent because of armpits of the Z. So technically, angle 3, it would be congruent to angle 4. And because of the parallel sides, you could also go this way, armpits of the Z. Angle 1 congruent to angle 2. Okay, so watch very carefully. Because of this, there's technically more than one shortcut going on here. If you just look at the armpits of the Z angles going this way and then going this way, we would be getting angle, angle, and then a side. That would be a possibility. But you're like, wait a minute, there's freebies there, which there are. There's also vertical angles. And if you add vertical angles into the works, then you have angle, side, angle rocking there. So technically, under this circumstance, either of those shortcuts could work. Occasionally, that is true. Watch out for double possibilities. Now that you've refreshed GIFT, I'm going to walk you through informal and then what are called formal proofs. First, we're going to do GIFT. And we're using a proof that you've done in the homework or the classwork from the previous lesson, so it should be familiar. Given, implied, freebies, talk through. Given, finger right there, lips moving. Let's read. It says AC right here bisects BAD, trace and sweep. That's a bisector this way. And BAD bisects going this way. Okay, we're done with these information. Implied. Of course, the bisector over here implies 3 and 4 are congruent. The bisector over there implies 1 and 2 are congruent. Freebies. AC is congruent to AC. That's reflexive. We're trying to prove that angle B and D are congruent. That's what we're ultimately trying to prove, the squiggles there. Let me do this in red. B and D, congruent. The way we're going to do that is where if we can say that the whole triangles are equal, then we can say the parts are equal. So we first have to say the whole triangle is equal. Then we can say the parts are equal. And of course, the whole triangle is going to be equal by angle, side, angle. So we already know where we're going here. Let me give you an example, and I'm going to color code it for you. Okay, we're going to do angle, and a side, and an angle. So, step number 1. We were given that AC bisects BCD, and that gave us angle 1 congruent to angle 2. There's your first angle. Then we know that AC is congruent to AC. Reflexive property, there is your side. AC bisects BAD because it's given. So angle 3 is congruent to angle 4. There's our other angle. That's a hamburger. Angle, side, angle. Because I can now say that the whole triangle is equal. That's our next step. So this entire triangle and this entire triangle are now congruent. So triangle ABC is congruent to triangle ADC by angle, side, angle. That would be the whole being equal, the whole equal. I now have said the whole is equal. Now we can go for our target. If the whole is equal, the parts are equal. Finally, angle B going to angle D by whole equal, parts equal, or the fancy name is corresponding parts, congruent triangles are congruent, CPC, TC. That's an informal proof because all you're doing is writing sentences. The next two are what are called formal proofs. They're a little bit more structured. We're doing the exact same proof, but just 3 different ways. So you kind of get a rhythm to it. Ready? Same piece of information here. Let me see if I can be... AC bisects BCD. And BAD. And again, we're trying to connect angle B congruent to angle D. We're following the same process. You can already see that we are dealing with a pair of angles, a reflexive side, and another pair of angles. That gets us the whole triangle equal. Then we're going to go parts equal. Now we're doing a 2-column. A 2-column proof reads like this. I know that because. So it reads like a sentence. Traditionally, we use these headings. Statements, reasons. But I prefer these headings because it's more descriptive. I know this statement because of this reason. So number 1, I know AC bisects angle BCD, BAD. Why is that true? We come over here. It is given. I'm going to go left to right. Number 2. You could do 1 and 2 first. It really doesn't matter. I'm going to go left to right. Angle 3 is congruent to angle 4. Why is that true? Because that is simply definition of bisector. That's what a bisector does. Why are those equal? Because of the bisector. And in the margin, we're going to keep track. That's a pair of angles. You can do this in various orders. I like to follow the order of the shortcut. So angle, side, angle. I could talk about both angles first and the side, but then some students get it confused as angle, angle, side. It's not. So I'm going to follow the order of the shortcut itself. So step 3, I'm going to say AC is congruent to AC. Why is that true? Reflexive property, that gives me a pair of sides. Angle 1 and 2, of course, are congruent. Why is that true? Definition of a bisector. Pair of angles. Fabulous. Now, again, we're trying to go for B and D. Whole equal, parts equal. So now I can say this triangle is congruent to this triangle. Why? Because of the shortcut you have right here, angle, side, angle. Now you can hit your target. Now that you've said the entire triangle is equal and this entire triangle is equal, we can now say step 6, angle B is therefore congruent to angle D. I'll give you both versions, the slang and then the technical. The slang would be this, which I will totally take. Whole congruent, parts congruent. That's the slang. The fancy corresponding parts, congruent triangles, are congruent. This is called a 2-column. 2-column. Statements, reasons. I know that because, I know that because, I know that because. And then you have your third style called a web proof. A web is the only style of proof that shows visually how pieces of information fit together, like pieces of a puzzle. So a web proof is the only one that shows visual connection. And I'm going to show you how it works for the same proof. Once again, AC bisects BCD. BAD. Given, implied, we just did the implied. Our freebie here, of course, is the fact that AC is congruent to AC. We know the triangles are going to be congruent by angle, side, angle. And if the triangles are congruent, then the parts are congruent, which are these two guys that we're trying to get. Now, a web is the only one that shows you how pieces of information connect together. So we're going to do this exact same proof. We have two starting pieces, the bisectors. So I write here that AC bisects BCD, that's one piece of information, and AC bisects BAD, that's another piece. And I split those pieces of information so you can see how things fit together. Now, you put the how statements in the boxes, like the what is going on, and you put the why between the boxes. So why is this piece of information true? It's given. Why is this information true? It's given. Now you take a next step. Because of this bisector, we get angle 1 congruent to angle 2. which is a pair of angles. And you put the y right above, and the reason is definition of a bisector. On the right-hand side, I got, because of this, we get angle 3 congruent to angle 4. There's another angle. Why is that true? Definition of a bisector. Now, what's up with this floating piece in the middle that's not connected to anything? It's not connected to anything because it's a freebie. It's not in the given. It's a piece of free information. And of course, our freebie is that reflexive side, and we write it like this. Let me do this in black. AC is congruent to AC. There is our side, and the reason why, reflexive. Now we can say the whole's equal, and then we're going to say the parts are equal. Because these three pieces of information combine together, this is the only time you can see how things combine. The two angles and then the one side all combine and converge to this triangle being congruent to this triangle. Reason why is angle, side, angle. This is the whole equal. Finally, because those triangles are equal, now you can say the parts are equal. Angle B is congruent to angle D. Reason why, corresponding parts, congruent triangles are congruent. You can see right here, a little star, whole equal, parts equal. We have done the same proof 3 different ways. The 3 different ways are narrative, just writing sentences, 2-column, I know that because, and something called webbing, which is the only one that shows how pieces fit together. Now, if I give you a completely what's called blank proof, an empty page, you can choose which method makes most sense to you. The next 2 proofs, because they're not blank, I'm going to force you to go through webbing because I think it's the most unfamiliar style. So we're going to do just 2 more. And so what I'd like you to do is this one and this one. Try it on your own. They should take about 5 minutes each. And then restart the video. Do the best to do this on your own. Pause the video. All right, students, I really hope you did pause the video. I'm going to go kind of fast because I'm assuming that you have actually done this and you're just getting your red pen and you're correcting. If you're getting stuff right, I expect, star, smiley, check mark, something. If you get anything wrong, totally okay. Just correct your work. We're going to do gift. You were given that is the midpoint going both ways. So given, implied, hatch mark, pair of sides. Double hatch, pair of sides. And then you should have caught your vertical angles in the middle, of course. I'm going to just add numbers to those to make it easy to work with. There's no rule that says you can't add numbers. You can. Pair of angles. So, why are these triangles equal? ABC, congruent to DEC, and you can see it's going to be because of side angle side. So how do the pieces fit together? Okay, let me tell you what's important. This order where you put the givens doesn't matter. One can go one or the other, or it could be switched. So I can write PE one side, C is the midpoint going this way. And the fact that C is the midpoint going this way. Those can be switched. Why? Given. I tell you they're given. What do you get from the midpoint? This one, you get B. C is congruent to CE. There's a pair of sides. Y, definition of a midpoint. Right here, what's true this way is AC is congruent to CD. Y, definition of a midpoint. There's your other side. Then you got the angles in the middle. Technically that's not given. I take that back. That needs to be fixed. You need to fix it too. That is not given. That is vertical angles. Angle 1 congruent to angle 2. There's your angle. Therefore, we can now bring this down over here. ABC congruent to DEC. Reason is side, angle, side. This one. So we're going to start by putting our given information on here. We are given that PQ is perpendicular to PR. That's right angle. We're also given that SR is perpendicular to SQ. We're also told that PQ is parallel to SR. Okay, there's your given information. Implied, because of those parallel lines, that's going to give us angles 3 congruent to 4 because of armpits of the Z. That gets us a pair of angles. Of course, because of the perpendicular lines, we get 2 right angles. So there's another pair of angles. And then we have, of course, a reflexive side. Given implied, there's our freebie. So you can see right now that this is a tail, an angle side. Now we're going to use this to fill out the web. Okay, so step number 1, we have our perpendicular angles right here, which gives us angles 1 and 2 are right angles, which forces them to be congruent. So that gets us a pair of angles. Why is that true? Definition of perpendicular lines. What else is true? The fact that PQ is parallel to SR. That's also given. And because of that, we get angle 3 congruent to angle 4. There's a pair of angles. Why is that true? Because alternate interior angles are congruent if the lines are parallel. There's your other pair of angles. And you have your reflexive side, which would read like this. RQ is congruent to RQ. That's why it's called reflexive. There's your side. And we know that those two triangles are congruent. PQR is congruent to SRQ, and the reason is angle, angle, side. Good job, guys. Take, again, your red pens. You should have been correcting these, not copying. Correcting, not copying. I'll see you in class.